Let's solve this. So, if this is new to you guys, earlier, last video, it was a uniform load. Now, this is called a triangular load. The main difference is the shape. The uniform load is a rectangle, and this is quite obviously a triangle. Now, what this ultimately means is that the the magnitude of this force is the area, right? So let's do the area to get the magnitude. 1/2 the base. So it's a triangle. Let's draw a mini one here. The base is 12 and the magnitude, well, the loading is 300, right? So let's get the area of this. So the area is going to equal the magnitude of the force, and that equals 1/2 base 12 times the height 300. So we're getting a magnitude force concentrated point load of 800 kilonewtons. So let's move this to the side and let's see where on a uniform beam, we know that in the rectangle, the centroid is, let me draw this correctly. Just gonna draw a straight line here. So it's 1800 kilonewtons, right? But where is it going to go? Right? So with the triangle, it happens in the centroid. Every force magnitude of any shape is going to happen in the centroid. But where is the centroid on a triangle? Well, it depends, right? Because this triangle is the highest magnitude is happening here at A and ending at B. If those, so the centroid, and there's a formula for this. So with this, this whole centroid of this triangular load would be 1/3 of the base. So if it'd be here, here. So if this was 1/3, it'd be right here. So let's apply this, right? Let's erase this, apply this. So what's 1/3 of this entire length? Let's say 1/3 times 12. 12 meters because it's 6 and 6. So it's happening at the 4 mark, 4 meters away from the origin. So let's draw 4. So if this half of this would be 3, let's do a little, so I'd say it's happening right here at 4 meters. So now I know that the magnitude of this force is here at 4 meters. Let's make that a little longer if it's possible. Let's just extend it upward. So this is 1800 kilonewtons. Okay, now we have the magnitude. Let's solve for the reactions AY and BY. Let's see. Let's sum the forces. Actually, I'm going to do this lower here. Let's sum the forces about A. Positive. It's going to be negative 1800 because it's tilting. It's trying to tilt the beam in this direction, right? So 1800 times 4 meters the distance. How far away is BY? It's 12 meters away. And sum of the moments should equal 0. Let's do the math. 1800 times 4. Let's quickly do the reaction divided by 12. So BY should equal 600 kilonewtons, right? Let's place that here. BY equals 600 kilonewtons of force. Now, that's 600 kilonewtons. So let's see what we get for the value of the vertical component, the vertical reaction of A. Let's sum the forces in the y direction. Okay, we got negative 1800 coming downward. Now we have 600 pointing upward. And I'm going to assume that AY is pointing upward as well. Just makes sense, right? Let's say 8y equals plus AY. We need to figure that out. That's our unknown. Let's do this math. It's negative 1800 plus 600. I'm getting negative 1200. If we were to put this on the other side, we get AY equals 1200 kilonewtons. Does that make sense? Well, we can check, right? 1200, does the force cancel out, right? 1200 plus 600 does in fact equal 1800. So we can confirm that this beam is under equilibrium. And this is how you solve a uniform, well, a triangular load to be exact. Okay, cool. Thanks for watching, guys.